Democritus was a Greek philosopher who many consider to be the father of science. He was a very influential philosopher and was taught by Leucippus. Democritus believed that all matter consisted of tiny, indivisible particles called atoms. He theorized that atoms are always moving and clustering in various temporary combinations. Some scholars believe that this theory was not his own, but rather that of his teacher. Democritus taught that an infinite number of atoms exist and that they are in constant motion. He also believed atoms had physical properties that could explain the properties of matter. The Greek philosopher Aristotle made many important contributions to natural philosophy. However, Aristotle disagreed with Democritus about the idea of atoms. Aristotle believed that no matter how many times you cut an object in half, you would always have a smaller piece of that matter. Aristotle's theory was that all matter was made from four elements: earth, air, fire, and water. As strange as that theory may seem now, it was used for 2,000 years before the scientific revolution swept it aside. In the later Middle Ages, Aristotle's work was rediscovered and enthusiastically adopted by medical scholars, who began to practice alchemy. These alchemists worked in secret and developed new laboratory techniques as they worked to transmutate cheaper metals into gold. Europeans began practicing alchemy to find the elixir of life, a potion that creates eternal youth, and also the philosopher's stone, which they believed would turn lead into gold. Although the alchemists never did find either of the substances they desired, they did discover some of the elements that we know today, such as antimony, arsenic, bismuth, zinc, and phosphorus. John Dalton was a British chemist and teacher. He believed that gases could only mix together if they were made up of tiny particles with lots of empty space between them. So he revived Democritus's name for these particles, atoms. John Dalton described atoms as solid, indestructible spheres that had no internal structure. In 1803, he proposed his atomic theory. It stated that all matter was composed of extremely small particles called atoms, and atoms of different elements possess unique characteristics and weights. J.J. Thomson was raised in England, and by the age of 14, his father had sent him off to Owens College to study experimental physics. After graduation, Thomson worked at the Cavendish Laboratory, where he experimented with cathode ray tubes. He discovered these rays were deflected by electric charge. This proved that the rays were made up of charged particles, which possessed a negative charge. He interpreted the deflection of the rays as evidence of particles much smaller than the atom. Thus, when Thomson was only 24 years old, he discovered the first subatomic particle, the electron. Ernest Rutherford was born in New Zealand, but eventually moved to England and worked with many other notable scientists. Rutherford's first discovery was radioactive decay, where a heavy atom can transmutate into two lighter atoms. This research with radioactivity is the reason he won the Nobel Prize in Chemistry in 1908, but he didn't stop there. Rutherford's experiments with gold foil and radioactive particles helped him to create a new model of the atom. His model featured a nucleus where positive charge was compressed into a very small volume. His experiments helped to discover this nucleus and eventually the protons in the nucleus. Niels Bohr was a Danish physicist who studied atomic structure and quantum mechanics. Bohr conducted experiments under J.J. Thomson and Ernest Rutherford. He is most known for developing the model of the atom where electrons occupy fixed orbits around the nucleus. He also theorized that the chemical properties of each element are largely determined by the number of electrons in the outer orbits of its atoms. He actually received a Nobel Prize in Physics in 1922 for his investigation of the structure of atoms. The electron had been discovered, but its behavior was still a mystery. Enter Erwin Schrödinger. He developed an equation that described the electron's position by a mathematical formula. This led to the electron cloud model, which displays a cloudy region where the electrons are most likely to be found. Mathematical probability, rather than inaccurate circular orbits, displays the likely locations of electrons. Schrödinger was then awarded a Nobel Prize in Physics for the discovery of this new feature of the atomic theory. James Chadwick worked with radioactivity and suspected that a strange beam of neutral radiation, which had been produced by other scientists, probably consisted of never-before-detected particles. As a colleague of Rutherford in the Cavendish Laboratory, he discovered the neutron in 1932 and then won a Nobel Prize in 1935. Unfortunately, Chadwick's discovery of this neutral subatomic particle prepared the way for the fission of uranium-235, and therefore helped with the creation of the atomic bomb.